So we got a couple of little mapping diagrams here, and I want to think about what's going on with these for a second. Remember, these are coordinates. So coordinates are inputs and outputs. So if I give you an input, you should be able to tell me the output that goes with it. So if I give you a 0, you give me a 4. That's basically what that means. So if I give you an input, you should be able to tell me the answer or the output that goes with it, right? So it would work something like this. Let's say I give you a 0. What are you going to give me? A 3. Oh, okay. So I give you a number and you give me back a number, right? What if I give you a 1? What are you going to give me?
A 3.
I give you a number, you give me back a number, right? What if I give you a 2?
4.
I give you a 2, you give me a 4. Okay, so on this guy, every time I give you a number, you're able to give me back an answer, right? Let's try it over here. If I give you a 2, what are you going to give me?
0.
I give you a 2, I get back a
0.
0. Okay. What if I give you a 5?
You get 6 and an
6 and 8.
Uh-oh. Do you know for sure what to give me back there?
No.
Give you both.
Why not?
Give you both of them.
Yeah, so if you send out an input and you're supposed to get an answer back, this makes a problem because if I give you a 5, well, do I give back a 6 or do I give back an 8? I don't know which one because it goes 2 places, right? So right here, I have a problem because I don't know which answer to give back for that. In math, we would say that these coordinates are a function. And these coordinates are not a function. So what a function is, a function basically, it deals with the relationship between coordinates. If every x that I send out, comes back with one answer, so basically every input only has one output, then it's a function. But if I have an input and I go, what's the output? And you go, there's more than one, then it's not a function. So the rule for a function is that every input can only have one output that goes with it. So this input has 2 different outputs, so it's breaking the rules. So I'm going to add that in here because that's basically what a function is. In order for something to be a function, every input has one output that goes with it. So if it's a function, every input has one output. I know you have a question. I'm going to have you hold on to it for 1 second because I want to show you one more quick thing and then I'll answer questions.
Wait, are we going to write something?
We were doing this in our diagram, right? I want to show you guys something else really quickly though. So this one was a function because every input you were able to tell me one number that goes with it. Okay, so that's the way to test it. So go through the inputs and ask yourself, what's the output? What's the output? What's the output? And if you get to any where you go, there's more than one answer, then you can stop because you know that that's not going to be a function. These are actually coordinates, right? Each of those arrows represents a coordinate. If I have coordinates, I could put them on a graph, right? I want to try that really quick because I want to show you guys what happens on a graph when something's not a function. So we're going to make a couple of quick little graphs. Okay. And we'll make our graphs count by ones. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so nothing fancy there. My first coordinate's 0, 3, right? 0, 3, 1, 3. So 1, 3 is right there. And then I have 2, 4. There's that one, right? It only has 3 arrows, so it's only got 3 points on the graph. This one also has 3 points, but the 3 points are different. So this is going to be 2, 0. So that'll be right here. 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And then 5, 8 is going to be up there, right? I highlighted the part of this that made it not a function. Where this broke is when I gave you a 5 and you went, there's 2 answers, right? The same 2 coordinates that made this not a function are right there on the graph. Visually, what do you notice about those 2 coordinates?
It has no start value.
One of them is like off the graph.
One of them's on top of the other. They're directly on top of each other, aren't they? So this is what happens when something's not a function. I have, because the inputs are down here, I have one input going 2 different places. So I've got one input with 2 different outputs stacked up on that same input. So if this is graph, the way you could tell yes or no, I can't have any numbers stacked up on top of each other. If I have things going this way, what direction do we call that? Up and down, we call that
Vertical.
vertical. So basically, if I have any points that are vertical, that means that I've got an input going more than one place and it's not a function. So no vertical points on a graph. That's called the vertical line test. So if you hear somebody talk about the vertical line test, that's what they're talking about. So in a diagram or in coordinates, I can't have one input that goes 2 different places. And on a graph, what that's going to look like is no points stacked vertically. If you look here, I don't have points on top of each other anywhere on that graph. So that graph's okay. This one's not. No vertical stacked
So if we were to
points.
graph